methods. We can look at question 2 and 3 from exercise A and C. Okay, so for 2, we've basically got 3 unknowns, and we need 3 equations to solve it. Okay, so we know a few pieces of information. Okay, it passes through this point, and also passes through this point. Okay, so I can sub these 2 points in straight away. Okay, so on my case, I'm going to go a squared y equals a squared plus bx plus c, given x equals 0, y equals 1. That's one equation. Okay. The other equation would be, I shall do the second one. So y equals a squared plus bx plus c, given x equals 2, y equals negative 9. Okay, so that's two equations done. Now we also know that this particular point is not also not just a point, it's also a stationary point, meaning the gradient, so dy dx equals 0 when x equals 2, because at 2 the gradient is 0. Okay, so you need to first find dy dx. So dy dx equals, I can do this by hand, so 2a x plus b, but we know that at dy dx equals 0, so meaning if I sub 0 for dy dx, the other one equals 2. So I can sub in x equals 2. Okay, and that's my three equations to solve for A, B, and C. So on the stack, if you get something like this, I'm expecting you to be able to solve it. So let's go on to our CAS. We're going to type this in. So all you need to do is go on our keyboard, set up simultaneous. So y equals, you use the VAR menu, y equals a squared plus bx plus c. Okay, and then we're going to use a given tool, given x equals 0, given y equals 1, negative 1. Okay, so done. Now, I'm just going to recycle this because I can use this for the second equation. I just need to change the numbers. So given x equals 2, y equals negative 9. Okay, because these are actual points on the graph, on the original equation. Now, for the third one, we know the derivative equals 0. So derivative equals 0 when x equals 2. So it goes back to VAR, x plus b, given x equals 2. Okay, I'm just going to go A, B, C, solving for A, comma, B, comma, C. Comma. Okay, let's do it. Great. Now, obviously, this question will be worth, like, let's say 3 marks. In order to, get the other 2 marks if you get something wrong, is you show your working. So I know that you've understood how to get, 3 of the equations. You may have made a typo on the, on your input, and for some reason you couldn't get an answer. Well, you've got to be able to show me some working so I can, so I can give you some marks. Now for question 3, it's a similar question. Okay, so ABC has a stationary point at 1, 2. So I can recycle what I've just typed in here. I know that when x equals 1, y equals 2. Okay, when x equals 0, the slope of the curve is 45 degrees. Now, slope of 45 degrees, I know we haven't done this for a while. I'll just give you the equation to find that out. M equals tan of theta. So the gradient of 45 degrees is equal to 1. That's from your trigonometry table of exact values. Okay. So we've got 2 pieces of information. We have a stationary point at 1, 2. When x equals 0, the slope is gradient of 1. Okay, so we're going to have to use the derivative equation. So we're not going to use this the second line because that's we don't have 2 points to sub in. We're going to have to use the derivative. Okay, so the derivative was 2ax plus b, correct? Okay, we know that the derivative is 0 at 1 when x equals 1. Okay, so when x equals 1, the derivative equals 0. Also, the derivative equals has a slope of 45 degrees, which means it's equal to 1 when x equals 0. Okay, so when x equals 0, so I'm going to type in 0 here, the derivative equals to 1, the gradient equals to 1. Okay, so you're solving for ABC, and you click enter. Okay, and you get your answer. So negative a equals negative half, b equals 1, and c equals 3 on 2, or 1.5. Okay, so the only difference between question 2 and question 3 is question 2, it's given you a point you can sub in, another point you can sub in to the original. So 1, 2, so you can sub into original, and then 1 point you can sub into derivative. Okay, when dy dx equals 0, x equals 2. Whereas question 3, there's a point you can sub in, 1 point you can sub in, and 2 points you can sub in for the derivative. Okay, so the derivative one, you know that when x equals 1, because it's a stationary point, the derivative equals 0. And then when x equals 0, the gradient, or the derivative equals 1. Okay, so hopefully that helps.